Welcome. Today we'll be going through some higher order questions pertaining to simple and compound interest. Do note that you'll need to bring a calculator. Firstly, let's make the distinction between the operations you'll need to know between simple and compound interest. Simple interest uses multiplication, division, addition, and subtraction, whereas compound interest requires knowledge of all the previously mentioned operations and exponential operations and logarithms. Here's a quick recap of exponential operations. 1. Roots are essentially powers with reciprocal numbers. A reciprocal is a number in which 1 is the numerator and the number is the denominator. 2. An exponent raised to an exponent multiplies the exponent numbers. In this case, m is multiplied by n. 3. An exponent multiplied by another adds the exponent numbers. Note, for the last two, the bases need to be the same. In this case, if x and b are different bases, then we cannot use 2 and 3. With logarithms, we simply use log, the base, to the final number the base gets to. The number outputted by this function is the exponent the base must be raised to in order to output the final number. As an example, log 10 to 100 is 2 because 10 squared is 100. Let's start with simple interest. Say we are given the accumulated amount of 1,200, a principal amount of 200, and an interest rate of 20% per week. We want to work out the number of terms. We start by writing out the equation a is equal to p1 plus I times n. Then we fill in our known values. After that, we use a combination of division and addition to isolate the unknown term. Thereafter, it's easy to solve. Let's try working out the interest this time, using a is equal to 1,200, p is equal to 200, and n is equal to 40 terms. Again, we write out the equation, fill in the knowns, and isolate the unknown on one side of the equation. Take note that when dividing or adding, you do the same to the left as you do to the right. We can now calculate 5 divided by 40 to calculate the interest rate. In this case, 0.125, which is 12.5%. Now we move on to compound interest. We are essentially working backwards, using our known values to trace the growth of our pi. If given a number of terms, we know how many steps of growth was required to grow our pi to its current size, and we just require proportion, aka interest, of its growth. If given the interest, then we know the proportion and can thus figure out the steps. This takes into account that we know the principal value and the accumulated value. This makes more sense in action. Let's take a is equal to 1,200, p is equal to 300, and n is equal to 40 terms. As always, we write out the equation and fill in the knowns. To get 1 plus I on its own, we take its 40th root. Note that the 40th root of x to the power of 40 is simply x to the power of 40 divided by 40, which is just x. This operation gives us the 40th root of 4, which is 1.035264, and so on. Take the 1 over, and we get I. Let's look at what happens when we know the interest but not the terms. Take a is equal to 1,200, p is equal to 300, and an interest rate of 5% per term. Let's go through the motions again. I'm sure you're very well versed by now. We eventually end up with this 4 is equal to 1.05 to the power of n. But how do we find n? We'll use logarithms. We take log base to the final value is equal to the amount of terms. So, filling in those values, we get 28.41, which is n. Should you raise 1.5 to 28.41, you will get 4. That's it. To get the best value from this video, redo the worked examples by yourself and compare the method and answers. If you have any questions, feel free to comment down below, and see you next time.